What would happen if you looked at the sky tonight and saw two moons instead of one? This intriguing idea opens the door to a myriad of possibilities about Earth's physical and environmental dynamics. It's time to dive into how multiple moons could reshape our planet. The moon we have plays a significant role in stabilizing Earth's axial tilt of approximately 23.5 degrees. This tilt is crucial for regulating our seasons. If we added additional moons, we'd see a dramatic alteration in that stability. The gravitational pull of multiple moons would likely cause fluctuations in the axial tilt itself. Studies suggest that without a large moon to balance the forces exerted by others, Earth's tilt could vary anywhere from 10 to 45 degrees over long periods. Such instability would lead to extreme weather patterns and unpredictable seasonal changes. Now let's talk about gravitational pull. Our single moon generates tidal forces that raise the ocean's water levels, producing tides typically ranging from 1 to 3 feet under normal conditions. Introducing another moon could complicate this situation. A second moon, depending on its distance and mass, could add its own gravitational influence. For instance, if both moons were roughly the same size as our existing moon, tidal heights could theoretically increase up to 50% or more in certain locations. Imagine tidal surges reaching heights of 15 feet or more, creating dramatic coastal effects. Additionally, the interplay between two moons would significantly alter oceanic tides. Current patterns feature 2 high tides and 2 low tides each day. If Earth hosted 2 moons, we could expect shifts to those cycles. Increased gravitational forces might lead to tidal frequencies of 3 to 4 high tides within a 24-hour period, so areas that typically experience calm waters could be transformed into regions of unpredictable surges and ebbs. The orbital mechanics of having multiple moons introduces another layer of complexity. If 2 moons orbit Earth, they would interact gravitationally. Such interactions can create complex orbital patterns, leading to minor or major perturbations in each moon's orbit. In scenarios with close encounters, we might witness moons altering their trajectories in ways that could lead to collisions. The stability we see with our current moon could be replaced with chaotic orbital dynamics. This chaos also raises the concern of potential collisions. With 3 or more moons, gravitational interactions would increase the risk of one moon being ejected or crashing into another. The mechanics of celestial bodies dictate that, over extended periods, such instability becomes a real possibility. Moreover, having more than one moon could also impact Earth's rotation speed. The gravitational pull from either an additional moon or altered configurations could lead to changes in the length of a day. Current models suggest that minor shifts might add or subtract minutes over epochs, making days shorter or longer. Let's also consider eclipses. Today, we experience solar and lunar eclipses at a predictable frequency due to precise alignments. Introducing new moons could lead to an increase in eclipse events, with multiple eclipses occurring within a single year, potentially creating a spectacle unseen in our current sky. The climate stability on Earth stems from its axial tilt and rotation, which is kept relatively stable by the moon's gravitational influence. Should multiple moons disrupt this balance, we could expect climate fluctuations akin to those seen on Mars, where the presence of Phobos and Deimos leads to significant instability in conditions, affecting the planet's atmosphere. Animals also rely on the moon's phases for biological rhythms. For instance, many species use lunar cycles to navigate and time reproduction. Changes to this rhythm, brought on by the presence of additional moons, could disrupt behaviors crucial for survival. In conclusion, more than one moon would likely make Earth's environment less stable and more chaotic. Given the dynamics involved, the chances of Earth maintaining several large moons in a controlled orbit are slim. A single moon remains integral to the stability we know today, so the idea of multiple moons, while fascinating, poses more risks than benefits for our planet.